Hello, science fans. Today we're diving into something that sounds like science fiction but is very real: acid rain. Acid rain is any form of precipitation, rain, snow, sleet, or fog, that's more acidic than normal because of pollutants in the air. Regular rain is a bit acidic, but acid rain can be as harsh as lemon juice, causing serious problems for forests, lakes, and even buildings. It's a hidden issue with effects everywhere, quietly damaging nature and our cities. Understanding acid rain helps us see how human actions can change our environment in big ways. So, let's put on our science goggles and explore what causes acid rain, its impact, and how we can fight back. Ready? Let's go! Let's break down the fascinating yet concerning chemistry behind acid rain. We'll explore the processes that transform ordinary rain into a corrosive force and understand the science that underpins this environmental challenge. It's a complex issue, but by understanding the chemical reactions involved, we can better grasp the scale of the problem and potential solutions. It all starts with two main pollutants, released into the atmosphere through human activities. These pollutants are the key ingredients in the formation of acid rain, and their sources are widespread across the globe. The first culprit is sulfur dioxide, a gas primarily emitted from industrial processes and the burning of fossil fuels. The second is a group of gases called nitrogen oxides, largely produced by vehicle emissions and industrial combustion. These harmful gases are released into the atmosphere from the burning of fossil fuels in power plants, factories, and, of course, from the exhaust pipes of our cars and trucks. The sheer volume of these emissions is what contributes to the severity of acid rain. Once released, these gases don't just disappear, they rise high into the atmosphere carried by air currents. There they mix with water molecules and oxygen present in clouds, undergoing a series of chemical reactions. This mixing and reacting leads to the formation of sulfuric acid and nitric acid, the two key components of acid rain. These acids are much more corrosive than normal rainwater. The wind plays a crucial role, as it can carry these acid-filled clouds far away from their original source. In fact, these clouds can travel for hundreds, even thousands of kilometers, spreading the effects of acid rain across vast distances. This long-range transport is what makes acid rain a global problem, affecting ecosystems and communities far removed from the original pollution sources. It's a stark reminder of how interconnected our environment truly is. To quantify acidity, scientists use the pH scale, a measure of the concentration of hydrogen ions in a solution. On this scale, 7 is considered neutral, meaning the solution is neither acidic nor alkaline. Any value below 7 indicates acidity, with lower numbers representing stronger acids. Normal, unpolluted rain is naturally slightly acidic, with a pH around 5.6, due to the presence of carbon dioxide in the atmosphere. However, acid rain can have a pH that drops dramatically, reaching levels as low as 4.2, or even lower in severely affected areas. Acid rain doesn't just fall as rain. It can also occur as wet deposition, including rain, snow, and fog, all carrying the harmful acids. But acid deposition can also take the form of dry deposition, which involves acidic particles and dust settling onto surfaces. Both wet and dry deposition contribute to the damage inflicted on the environment, our infrastructure, and even our cultural heritage. In essence, pollution goes up into the atmosphere, undergoing a chemical transformation, and then acid comes down, impacting ecosystems and human-made structures alike. So, that's acid rain in a nutshell. A consequence of our industrial activities and a challenge that demands our attention. It's science in action, revealing the complex interplay between human activity and the environment, and highlighting the importance of responsible environmental stewardship. Where do these acid rain-causing chemicals come from? Mostly from burning fossil fuels like coal, oil, and gas. Power plants burning coal are the biggest source of sulfur dioxide. Cars, trucks, and planes produce nitrogen oxides when their engines burn fuel. Factories making steel, paper, and cement also release these pollutants. Nature adds a little: volcanoes, forest fires, and lightning, but humans produce far more. Our demand for electricity and transport is the main driver behind acid rain. The challenge: the same things that power our lives are also polluting our air. Solving acid rain means rethinking how we create energy and travel. When acid rain falls, it quietly damages forests and waterways. In forests, acid rain strips protective coatings from leaves and leaches nutrients from soil while releasing toxic aluminium that harms tree roots. Trees become weak, more vulnerable to disease, cold, and pests. In some regions, entire forests have been left bare and dying. Lakes and rivers suffer too. Acid rain lowers the pH, making water too acidic for many fish and aquatic creatures. Shells of snails and crayfish dissolve, fish eggs don't hatch, and whole food chains collapse. Some lakes become crystal clear but lifeless, dead lakes. Birds and animals that rely on these waters also disappear. Acid rain unravels entire ecosystems, all from invisible pollution. The damage is slow, silent, and devastating. That's why it matters. Acid rain doesn't just harm nature. It attacks our cities and history too. Many old buildings and statues are made from limestone or marble, which dissolve when hit by acid rain. Over time, details on statues blur, inscriptions vanish, and stone structures weaken and crumble. Even modern materials aren't safe. Acid rain corrodes metal, rusts bridges, and damages car paint. The cost of repairs runs into billions every year. Our cultural heritage and infrastructure are at risk from the same pollution harming our forests. Acid rain connects the fate of nature and civilization. Protecting one means protecting both. Let's take a closer look and see acid rain's impact in the real world. We're not just talking about abstract concepts here. This is about tangible damage to our environment, our history, and our future. Acid rain is a stark reminder that pollution doesn't stay put. It travels, transforms, and leaves a trail of destruction in its wake. In Germany's Black Forest, a region once renowned for its lush greenery and vibrant ecosystem, acid rain, a direct consequence of industrial pollution carried by the winds from distant factories and urban centers, killed vast areas of trees in the 1980s, leaving behind a skeletal landscape as a grim testament to the devastating power of unchecked emissions. The forest struggled to breathe, its natural defenses overwhelmed by the acidic onslaught. Scandinavia's lakes, once pristine and teeming with life, with little natural protection against acidity, lost all their fish, their delicate ecosystems collapsing under the weight of the pollution. The water became a silent graveyard, a stark warning of the fragility of nature. As acid rain, originating from other countries with less stringent environmental regulations, fell relentlessly upon their surfaces. This transboundary pollution highlighted the interconnectedness of environmental issues. In North America, the Adirondack Mountains, a region famed for its stunning natural beauty and clear lakes, saw lakes turn lifeless, their waters becoming so acidic that they could no longer support aquatic life. The vibrant ecosystems that once thrived were reduced to barren landscapes, and forests decline, their health compromised by pollution blown in from afar, carried on the winds from industrial heartlands hundreds of miles away. The trees weakened, becoming vulnerable to disease and pests. Even world landmarks, testaments to human history and cultural heritage, suffer. The Parthenon in Athens, a symbol of ancient Greek civilization, and the Taj Mahal in India, an architectural marvel and a testament to eternal love, have been damaged by acid rain, their surfaces slowly eroding under the corrosive effects of airborne pollutants. These monuments, meant to last for centuries, are now threatened by a modern-day scourge. These examples, spanning continents and cultures, show acid rain is a global problem, a challenge that transcends national boundaries, crossing borders and harming both nature, the ecosystems that sustain us, and culture, the monuments that define us. Pollution created in one place, often far from the site of the damage, can devastate another, highlighting the interconnectedness of our world. Acid rain's reach is long, and its effects lasting, leaving scars on the environment that can take decades, even centuries, to heal. That's why international cooperation is crucial, essential for tackling this pervasive environmental threat. The world is connected by air, the very air we breathe, water, the lifeblood of our planet, and responsibility, a shared duty to protect our planet for future generations. We must act together, or we risk losing the very things that make our world so precious. The good news, despite the challenges we face with acid rain and other environmental issues, there's a reason to be optimistic. We can fight acid rain, and we already are. Around the world, dedicated individuals, organizations, and governments are taking action to combat this problem. Power plants now use scrubbers, sophisticated pieces of technology that play a crucial role in reducing emissions. These scrubbers work diligently to trap sulfur dioxide before it escapes into the atmosphere, effectively turning it into harmless gypsum, a common material used in construction. Many power plants and industries have also switched to cleaner fuels, such as natural gas, which produce significantly less sulfur dioxide and other harmful pollutants. Furthermore, there's a growing shift towards renewables like wind and solar, harnessing the power of nature to generate electricity. These renewable energy sources don't cause acid rain, offering a sustainable and environmentally friendly alternative to fossil fuels. Cars are also becoming cleaner, thanks to catalytic converters that efficiently turn harmful nitrogen oxides into harmless gases like nitrogen and water vapor. Governments have recognized the urgency of the situation and have passed laws and forged international agreements to limit pollution and promote cleaner air. Landmark legislations like the US Clean Air Act and various European treaties have played a pivotal role in setting emission standards and driving environmental improvements. These efforts have yielded remarkable results, with sulfur dioxide emissions being cut dramatically across many regions. As a direct consequence of these pollution control measures, acid rain is becoming less acidic, posing less of a threat to our ecosystems. Encouragingly, some lakes and forests that were once severely affected by acid rain are now showing signs of recovery, a testament to the effectiveness of our actions. Fish are returning to these waters, a clear indication that the aquatic ecosystems are beginning to heal. The ecosystems are healing, showcasing nature's resilience when given a chance to recover. This progress demonstrates that science, teamwork, and smart policies can indeed work wonders in addressing environmental challenges. The fight isn't over, and there's still much work to be done to fully restore the health of our ecosystems and prevent future damage. But we've proven we can make a difference, and that gives us hope and motivation to continue our efforts. When we act together with a shared commitment to protecting our environment, we can heal our planet and create a sustainable future for all. You can help fight acid rain too. Save energy, turn off lights, unplug devices, and use less electricity. Walk, bike, or use public transport to cut pollution from cars. Support clean energy and energy-efficient appliances at home. Share what you learn about acid rain with friends and family. Encourage others to make greener choices. Reduce, reuse, and recycle to save energy and resources. Plant trees. They help clean the air and soil. Every small action adds up to big change. You don't need a lab coat to be a science hero. Start today. We've seen how acid rain forms, spreads, and harms everything from forests to historic buildings. But we've also seen that science, innovation, and cooperation can solve even global problems. The fight against acid rain shows we can fix our mistakes and help nature recover. It's a lesson for other challenges like climate change, pollution crosses borders, and solutions require teamwork. Every action counts, from turning off a light to supporting clean energy. Protecting our planet means protecting our own future. We're all caretakers of this amazing world. Stay curious, keep learning, and let's work together for a cleaner, healthier Earth. The story of acid rain proves, together we can make a difference.